Welcome to Section 5 of Built-Up Roofing Damage Assessment. In this section, we're going to look at hail and wind-caused damage to built-up roofing. To do this, we're going to discuss the functional damage definition for hail impact, and then look at specific examples of hail damage and wind damage to built-up roofing. At Hague Engineering, over many years, we've developed a general definition of functional hail-caused damage to roofing. And that would be one of two things. If you have a diminution of water shedding capability or something that would cause a reduction of expected long-term service life. And then specifically applied to built-up roofing, that would be puncture, fracture, or bruise through the membrane. And this is going to take fairly large hail to do this. And normally this manifests itself as concentric circular fractures from a large hail impact on the roof surface. This would be something that potentially could cause leakage into the roof system. The second type of damage is if the flood coat or coating is dislodged from the roof surface. This would not be as serious and likely could be addressed by repair to the flood coat or coating itself. When doing an inspection of a built-up roof for hail-caused damage, you must understand that there are areas that are going to be more easily damaged and areas that are fairly well protected. So first, look at the parts of the roofing most sensitive to damage. These would be areas with fewer plies of roofing and that are marginally supported, such as the base flashing of parapets and curbs. Often these might only be one ply of material. And blistered areas of the roof. These could be one, two, or possibly more plies of roofing, but they are not as well supported and because of that easier to damage. Also, if there are bare areas or extensively weathered areas, they also would be more sensitive to damage than the typical field areas of the roof. Built-up roofing is one of the more hail impact resistant types of roofing, and so the typical damage thresholds would be 2-inch diameter to damage a smooth surfaced built-up roof. That's without any gravel. If you have gravel ballast, then it typically takes 2.5-inch diameter hail. If hail of that size has fallen, you're going to see indications of it in many different ways, and then you'll know you have the potential for damage to the built-up roof. Once you get to the field areas of the built-up roof, you can examine it in test areas. Now you do have to consider the size of the entire roof and how many test areas you would need. If there are sections of the roof that are different ages, they would each require a test area or separate examination. Or if you've got a large enough roof that you've got expansion joints or area dividers, they also would have to be each looked at. Once you get to your test area, if it's gravel ballasted, first look to see, are there areas where that loose ballast has been scattered or cratered out by hail impact? If so, then that's the area to look at more closely at the surface with either a small whisk broom or some sort of implement to move away that gravel ballast and get to the surface. If the hail impact was bad enough to damage the roof membrane, there also should be broken pieces of flood coat and asphalt that would be dark black in color in that area. Also, you could do a more general sweeping of your test area to remove the loose gravel ballast, and then we're looking to see is any of the embedded gravel dislodged from the surface, or do you see or feel actual fractures in the roof membrane with or without water oozing out of them. So that's when you get down up close to look for these punctures, fractures, and dislodged surfacing. If it's happened recently, the exposed asphalt surfaces are going to look dark black and glossy. If there's an area of potential damage, it's good to get down and feel it with your fingers for a soft spot. The hail is a downward impact from a large chunk of ice falling out of the sky, and so if it hits the membrane, it's going to be fractured in a downward manner, and so that can feel soft either to hand pressure or foot pressure. If you see or feel that on the roof, but you don't see an actual fracture or puncture in there, that still potentially could be damage, and you could consider that as an area to do a test cut potentially. We're going to talk about test cuts a little more in the next section of this course. If you've identified actual areas of hail damage in your test area, quantify those, and in addition to that, you're going to have to quantify the damage to the more susceptible areas, such as parts of curbs and parapets that may be damaged. Hail that's wind-driven may only affect one side of the parapet, such as a westerly-driven hail would affect the curbs and parapets that face west. Maybe you've got damage facing more than one direction. So that's another type of damage you've got to quantify. Also, do you have damage in the bare areas or blistered areas? If so, quantify that in addition to what you find in the field of the membrane. Now, is there any evidence of water infiltration related to the hail impact? If there is a severe fracture or puncture you see in the membrane, you may actually see or feel a wet spot in the insulation underneath. If so, that is going to add to the amount of repair that would have to be done. And it also makes you want to try to quantify or get an estimate on how much insulation is wetted in the roof. And you can do this in a couple of different ways. One is through an actual test cut. Again, this would not be done by yourself if you're just an inspector. You would need to have a roofing contractor involved. But by opening it up, you can verify if there is moisture in the roof system. Once you see at least some moisture in the system, to understand how much moisture there is, there are various non-destructive testing methods, abbreviated as NDT. And so once you understand the extent of hail damage and also the extent of moisture in the roof system, then you can determine, is a repair reasonable? Meaning, is it feasible for us to find, or a contractor that's going to do the repairs, to find all the damaged areas? Can he repair any moisture that's in the system, and can he do all this economically? We'll provide a little bit more information about these non-destructive test methods. Typically, these are going to be done by consultants, engineers, inspection services, and possibly some contractors might have these capabilities too. There are electric capacitance meters. That's what's shown in the photograph on the right. They use the fact that wet materials are going to conduct electricity more easily than dry materials. And so it's an indirect method of trying to figure out if there's moisture in the system. Infrared cameras are going to measure the temperature of the system, and that also can lead to the implication that there is wet insulation. There's also nuclear hydrogen detection gauges that can be put on the outside of a roof surface. And there's also another system called electric field vector mapping that also uses the electrical properties of wet materials to determine exactly where wet insulation is in the roof system. Use of these non-destructive test methods can help you determine where the items that are wet need to be removed are, what sort of percentage of the roof system also has moisture in it. It's important to realize, though, that just because there's moisture in the system, that doesn't mean it was caused by a hail impact. It could be by any other method, from just specific deficiencies to long-term wear in the roof system. And even if there is some hail-caused damage, that doesn't necessarily mean that's the source of the moisture in the system. But by looking at all the information and maybe the help of other consultants or experts, you can help to sort that out. Another important point is you don't want to just go by the non-destructive test methods. They also need to be confirmed. If your capacitance meter is indicating there might be moisture in this one area, you need to do a test cut. Have a contractor take a test cut to confirm that. So you want to confirm that areas you think are wet, and you also want to confirm areas that you think are dry are actually dry. And that confirmation will help give you the full picture. Here's some examples of some photographic images and infrared images of the same roof. On the upper left, we've got the actual photograph. The upper right is the infrared image. The brighter colors on that infrared image are showing warmer temperatures, and so wet insulation will lead to warmer temperatures in the roof. The best time to do an infrared survey is during the night. And so because of this, they have to be careful, and you don't always get to see what the flaws are. So the areas that showed up as bright in the infrared image were then painted and marked on the roof in the photograph seen on the left, and then they can become and checked later the next day. Same thing in the bottom images. The lower right infrared image shows some certain bright areas that implied that there could be some wet insulation. Those are then marked on the roof and then checked at a later time to see, can the defect be found, and also can you actually confirm that there is wet insulation in that area. Now to some specific hail damage examples. Here we've got a large impact on a base flashing of a parapet. And that particular impact is nearly 3 inches across. And so hail of that size not only damaged this parapet, that's large enough size to cause damage out in the field of the roof. And seeing indications like that tell you you're going to have to do a very thorough, complete inspection and looking at damage in the field of the roof as well. Another photograph of hail-caused bruises in a parapet flashing. We see several dark black areas where the aluminum coating was spalled off, and then you can look to see, is there a fracture, is there a puncture in those areas? And if so, those would be other things that could let water into the roof system. Those parapet flashings often are only one ply and are much easier to damage than the field of the roof. The aluminum coatings will have some general cracking that happens with time, but cracking related to impact will normally create concentric circular fractures, such as you see near where the finger is pointing in the photograph. By then feeling that area, looking at it more closely, you can determine, is the damage just in the coating, or did it actually bruise or fracture the felt as well? Here in this photograph, a blistered area of the roof that was unsupported had been punctured through by hail impact. The felt is fractured through and dark black asphalt is exposed where that hail impact had occurred. Just because you see hail impact damage to a blister, though, does not mean that hail has damaged the flatter portions of the roof. The blisters are much more sensitive because they are fewer plies and also less supported and sometimes more weathered material. When you have gravel ballast on a roof, it doesn't mean that you can't determine that there's damage, but you do have to know what to look for and how to do that inspection. The photographs on this slide show a roof with a pretty high quantity of loose gravel ballast, and it was hit with large hail. All those dipped areas on the roof surface are where large hail has come in and cratered out the loose gravel ballast. And so as you find the bigger spots like that, that gives you the place to look further to get down to the roof surface to see if there was any actual damage. There may not be, but at least by seeing the evidence in the loose gravel, you know where the larger hail impacts have been. Once you sweep away that loose gravel ballast and get down to the roof surface, in this photograph we see that the flood coat and the actual embedded gravel ballast have been broken away by the hail impact. The exposed asphalt is dark black, and by feeling it with your hand, you could detect a soft spot in the roofing. That would be considered our hail-caused bruise or fracture. If it's unclear whether it's broken through, again, this could be an area that you would mark for a potential test cut. This photograph shows a spalled area of flood coat and also some very fine concentric circular fractures at the impact point. And so by feeling that area, if it feels weaker or softer in that area relative to areas on either side, that would be an indication of hail-caused damage to that point. A smooth surface roof, such as this one with aluminum coating, makes for an easier inspection. Any hail impact spatter marks may be visible on the surface. If there are the concentric circular fractures, such as are circled in chalk, they are readily visible. The question then is there damage to the felt plies or just to the coating? And you can tell that by close inspection, by feeling for soft spots, for weakened areas, or if it's still unclear or if there's disagreement, you could take test cuts in some of those areas. This photograph shows a close-up of concentric circular fractures on an aluminum-coated roof. Some of the coating actually spalled away, exposing the dark black surface underneath. If the damage is limited to the coating, then the roof surface can be cleaned and recoated. Now switching to wind damage. When wind affects a roof, it can cause damage in two ways. What we term direct damage is when the wind forces itself peel off or remove portions of the roofing. Indirect damage comes from debris impacts. And so if items on your building or adjacent buildings or foliage are being blown around by the wind and they impact your building roof, that can cause impact-related damage from the debris. So those are the two forms of wind damage that you've got to look for when you're out on the roof. Part of the overall assessment of a wind inspection is determining what is the strongest direction of the wind. And that will help determine which corners and edges and sides of the roof that potentially would be most affected, and also which direction wind-driven debris would be blowing across the roof. The areas where you expect to see damage first on a low-sloped build-up roof would be corners and edges are damaged much more easily than the field zones. If you've got perimeter cladding or coping and it's not well attached, these could be torn away and blow across the roof. If you have areas where windows or doors fail in the building and the wind pressures get inside, that can cause additional pressure on the underside of the roof and cause the roof to blow off. And again, if there's evidence of wind-driven debris. If there's evidence of debris blowing across the roof, now you're looking for punctures, tears, and abrasions, somewhat similar to what you'd see from hail damage, other than they're going to follow a pathway related to the source of debris, and depending on what type of debris it is, these sometimes debris marks might be quite large and quite severe. If there are areas where the roofing has been peeled back or displaced, normally these are pretty easy to see, but you would have to determine what is the size of the area of removed roofing, damaged roofing, and also, once water gets in that system, how far has the water reached underneath the roofing for the insulation. Potentially, there might be the need to do test cuts or use that non-destructive testing to help you determine the extent of moisture. And then ultimately, once you've determined the scope of damage, is a repair reasonable? Can you define it? Can you determine, is it economical relative to roof replacement? In a large roof, too, there might be certain sections that have more damage than others, and potentially the level of repair varies by building section. In this photograph, we're looking at wind that was approaching the building through that upper left corner. When the wind hits that corner, it often splits into a V-shaped pattern, and we have ballast that has been scoured or moved on the roof. So wherever that ballast has been moved, that tells you that's where the strongest winds were on this asphaltic built-up roof. That's what the ABUR abbreviation stands for. In this photograph, though, we see that no roofing actually was removed, and after close inspection, if that's the case, then the repair here would be limited to moving the loose gravel ballast back to its original position. In this photograph, we do have roofing and insulation boards that were removed starting at the edge of the building on the left side of the photograph. Now that the roof is open, moisture can get underneath that roof decking, and you've got to verify just how far the moisture has gone, how much wet insulation you have, and what are the damaged areas of the roof relative to the size of that roof or roof section to determine whether a repair is feasible. The photograph on this slide shows removal of roofing starting at a corner, and there also is several types of debris that is being tipped over and scattered around this roof. So you've got a certain area of roofing removal, a certain area of insulation removal, and then you've got to look at the debris impact damage from the air conditioning units that were tumbled, some of the parapet wall materials that were tumbled, and determine a scope of damage related to all of those causes on this roof. Just the lower section of the building in this slide were damaged by wind, the open canopy section. And then looking more closely in it, in the lower right photograph, we see that the attachment of the insulation board was via mopping of asphalt as opposed to mechanical fasteners. But yet the dark asphalt residue that's on the top of that metal deck does not have much, if any, insulation board attached to it. So it appears that the asphalt cooled and hardened before they put the insulation board. And so even though wind clearly did remove this roofing, a contributing factor was the poor installation and weak attachment of the insulation board to the roof decking in this instance. And so that's where sometimes expert assistance and engineering assistance is necessary, not just to determine is there wind damage, but also why. Why did the wind damage occur, and did it occur at a wind speed that was at or above code level wind speed for that region? In this photograph, we're looking at debris damage. A lot of times the source for debris is things that are actually on your roof, like air conditioning units. If they're not securely tied down, they can be toppled and flipped over, and so you've got damage to the roof system from the air conditioning unit. That concludes Section 5 of Built-Up Roofing Damage Assessment. Now it's time to proceed to your section review and quiz.